Please bear 5 more minutes for any more participants to participate in the meeting.
Hello, Suman sir. Hello. Hello.
Yes, sir.
Am I audible?
Yes, sir.
Okay, thank you.
Welcome, sir.
Good afternoon, everyone. I hope you all are feeling inspired and after yesterday's insightful session on research and innovation, undertaking understanding technology readiness levels, the depth of knowledge shared by Dr. Royston Vijay Castellino, and the engaging discussions shared that followed truly set a high bar of our week together. Today, we are privileged to continue our journey with another esteemed expert in the field of mechanical engineering. It is now my absolute honor to introduce our distinguished speaker for the day, Dr. Ranjit Krishnan. Dr. Krishnan is a beacon of innovation and knowledge in mechanical engineering with a specialization in biofuel, waste management, and machine learning. His academic journey led from the University of Kerala and the University of Calicut to achieving his PhD from National Institute of Technology, Mizoram in 2022, where he made significant strides in the study of bamboo biodiesel. Currently, Dr. Krishnan is an assistant professor at Savita Engineering College, affiliated with Anna University, a proud member of All India Council for Technical Skill Development. His industrial and teaching experience combined with his passion for research have resulted in noteworthy contribution to engineering and education, including publication of biomass and biodiesel from Indian bamboo. Beyond his academic and research pursuit, Dr. Krishnan has also shown in sports, being a national level silver medalist in boxing and a gold medalist in powerlifting. His multifaceted achievements underscore his dedication not just to academia but to personal excellence. But before we dive into today's session, I would like to invite our beloved patron, Dr. Shomik Chakraborty sir, to share a few opening words with us.
Okay, thank you, ma'am. Thank you for a wonderful introduction for me. Okay, am I audible? Hello.
Yes, sir.
Yeah, good afternoon, everyone. On behalf of RERF Group of Institutes, myself, Dr. Somik Chakraborty, heartily welcome Dr. Ranjit Krishnan for the today's topics on artificial intelligence and machine learning. This is one of the demanding topics, starting from biology to any kind of engineering, even some kinds of the art subjects, even to the history, finding out the prediction of history or etc. statistics. Everything. The machine learning is everywhere. So I hope our faculty members will benefit it in their academic as well as research purposes to learn positive outcomes from the machine learning techniques, whatever it may be. I think so. They will be benefited in deep learning, neural network, whatever, maybe some regressions technique, whatever may be, they will be benefited on that. Thank you, welcome, Professor Krishnan. Thank you.
Sir, am I sir?
Thank you, Dr. Shomik sir, for those encouraging words for setting the stage for today's exploration. Ladies and gentlemen, fellow students, and esteemed faculty, please join me in warmly welcoming Dr. Ranjit Krishnan to take the platform and enlighten us on machine learning, a new frontier in creative problem solving. The stage is all yours, sir.
Okay, madam. Am I audible? Hello, hello.
Yes, sir.
Hello.
Yes, sir.
Okay. Shall I share my screen?
Yes, sir.
Yes, sir. Can you see my PPT?
No, sir.
Hello.
Yes, sir.
Hello.
Yes, sir.
Can I see visible
Yes, sir. You
my
are
PPT?
visible, but your PPT is not visible.
Can you visible my PPT? Hello. To Suman of Region Education opportunity to conduct a session on the topic machine frontier in creative problem solving. We don't have that much of time, so I am coming to the content page. So which I am going to discuss. Okay, can you see my PPT now?
Yes,
Yes,
sir.
sir.
Okay, okay. Sorry for the network glitches. Something is happened in Chennai from past 2 days. Okay, sorry for that. So these are the my contents which I am going to discuss today. First one is the introduction of machine learning, and second one is how this machine learning works, and third one is the most important part of machine learning, that is data. So and how much memory is allocated for each and every data. That is the fourth section. And some of them have some questions related to whether this artificial intelligence and machine learning is same or not. That we are going to discuss. And next section is about the different types of machine learning, which nowadays we are mostly using. And next three section is related to the applications of machine learning in mechanical engineering, civil engineering, electrical and electronics engineering. So nowadays, especially our engineering college students are just little bit confused why we are choosing machine learning in our core subject fields like mechanical or civil or electrical and electronics. So I am going to discuss some of the applications related to that fields. And second last one is the case studies of case studies. Well, I am just taking one case studies, and the case study is related to the prediction of surface roughness equation for mild steel in turning process. That is purely mechanical background, but it is everybody can understand. It's a simple topic. So I am going to discuss some of the case study related to the machine learning. And last one is about the disadvantages. So before going to introduce my class, I had to. There are some in basically engineering student doesn't have knowledge about what is science, what is engineering, and what is technology. As a faculties also, we are also bit confused about what is science, what is engineering and technology. So anybody from the participants, and can you please explain what is science, what is engineering and what is technology? Anybody?
Sorry, sir. Can you repeat?
So from our participant sides, I have one question to the participants, that is, can you give a correct definitions for what is science, what is engineering and what is technology? Because when we enter to a classroom, and first of all we are teaching from the, for example, if I am taking thermodynamics or any other solid state devices also, we are just teaching from that, we are leaving from the class, but we are not telling them why we are choosing that particular subjects, or what is it related with science, or what is it related with engineering, whether it is a technology. Am I correct? So my question is, what is the definition for a, can anybody give a good definition for science, engineering and technology? Anybody?
Sir, my name is Sridip Ghosh. Can you hear me, sir?
Yes, sir. Yes, sir. Yes, sir. Can tell me, sir.
Sir, actually, in my opinion, I think s- the definition of science is finding the cause of everything. And the definition of
Yeah.
engineering is to design according to the cause. And the definition of technology is to implement the thing. I am not sure, sir. It's in from my own mind I
Yeah.
told.
Yeah, it's your about 90% your answer is correct, sir. Actually,
Oh,
science
thank you,
is
sir.
we are finding the actually the science is we are finding the curse by using some evidences. That means correct evidences, not fake evidences. We are using the actual evidences. We are finding the curse of a particular phenomena. That is, we can say science. Engineering is not only a design, but it is, we can simply say it's an application of science where we are applying that science. For example, electricity, we can say it's a science, and and the product which is used by electricity, like our bulb, what is that, our fan and everything, we can say it's an engineering process. That is, we can say science. And so we can say that is the upgradation of an engineering itself. That is, engineering itself is a new engineering. That means a technology. Program is related to So I
Sir,
am collecting
we
the
we
existing
can't
data
hear
and
your
I give
voice.
some.
This is
Uh,
buffering.
Hello.
Sir, your voice is breaking, sir.
Think some network. Am I audible now?
Yes, sir,
Hello,
you are
sir.
audible.
Okay. Sorry. Some network glitches is going on because our college is some of the server problem is there. Sorry for that. So the term machine learning was first introduced by Arthur Samuel in 1959. And also, we can simply say it's to automatically learn from the data, improve performance from the experience, and predict things without being explicitly programmed. That means simply we can say that if I am creating a robot, and the robot only I am only designing the robot for walking purpose only, not for any climbing purpose. But if we walk through some area and if we found some step, he will stop that. The robot will stop because I only programmed up to for walking purpose only. Means if a step will come, I will climb that. That the robot will climb. So these things are happening due to the machine learning. So that from the collection from the past history, it will collect the information and it will regenerate. Simply we can say it's a one example of machine learning algorithm is created by using some algorithms. So this from the collection of data only we can say that machine learning algorithm is created by using some input past data. After that, it will create some logistical models. From the logical models and the new data which we are going to input, and it will generate the output. So these things we can discuss next slides. Then only you will understand more. So for this machine learning, the main important part of the machine learning is the data. So the data means simply we can say it's a collection of information. By this information only we can predict some equations and we can make some logical models. So the you can see nowadays that as of the 2022, every minute of a day, we can see that so much of data are shared everywhere. For example, our data. So you can, sometimes you can see some spam mails like that. You won a lottery, and if you pay 10,000 rupees, you will get 30 lakh rupees like that. So many spam messages nowadays we are getting in our mail. This is mainly due to our data is shared by somebody. So now the data protection is very important things. So most of our personal data are not at all secured in our things. So this from the collection of data only we can generate some machine learning algorithms. So data is an important part of that one, and the memory of the data is allocated as follows. For example, for letters and alphabets, a single letter on the computer takes only about 1 byte of data. But in the case of a single page of a journal book, it will journal paper, it will take around 1 KB. And if you consider a the book with 1,000 pages, it will take 1 MB. This is how the inform. This is the example for 1 gigabyte and 1 terabyte and also 1 exabytes. So 1 exabytes you can see if you take all the details of the Amazon rainforest, that means around 700 billion trees. We can say it's a 1 exabytes of data. But estimates from the studies of 2023, the world was generating around 3.5 exabytes of data daily. So that much of data we are getting daily. From this data only, we can say that we will get the machine learning algorithms. So another question rises every time is AI and ML are same? Actually, it machine learning is a part of AI. Actually, it's a subset of, we can say it's a subset of AI. Because for AI means artificial intelligence. This artificial intelligence is created by using some algorithms. See, these algorithms are created by machine learning. So we can say it's a machine learning is a subset of AI that focus on enabling machines to learn from data and improve without any explicit programming. And moreover, the different types of AI, we can say, for example, weak AI is there, general AI is there. For example, in iPhone, we can say Siri, and in Alexa, all are coming under this AI. But in the machine learning, only some equations, predictive equations. From these equations only, we will generate some AI. So the question is AI and ML same? Means the answer is that the machine learning is a part of artificial intelligence, or it's a subset of artificial intelligence. Then coming to the main important topic, that is the different types of machine learning. So here you can see so many machine learning types are there: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, transfer learning, self-supervised learning. So before going that, we have to understand what is labeled data and unlabeled data. So labeled data means we can say the alphabets, numbers, all things are coming under the labeled data. So we will retrieve the information from this particular alphabets or the signals which is existing from the existing data. We are collecting the alphabet and numbers, and we will go for predictive analysis. So that type of thing is coming under the supervised learning. And some of the examples you can see that linear regression. That is simply we can say ANOVA. ANOVA is one of the supervised learning. But for the ANOVA purpose, we don't need to study any coding or anything like that. We have to give the input and output. At the same time, we have to give the input and output, and number of iterations also we have to give it. Then we will generate some predictive predictions. So today in the case study, I am going to discuss some of the example of the linear regression method. Then another important, and nowadays mostly we are using artificial neural network. So for that purpose, we should have some knowledge in Python. So if you have good knowledge in Python, you can create so many type of equations, or you can iterate so many type of equations. So all things are coming under this supervised learning. If you take a journal of any machine learning from any science director or Springer or any other things, you can see most of the machine learning purpose are related to the supervised learning. So it is an important machine learning type. And second one is the unsupervised learning. In this unsupervised learning, the main problem is that it will retrieve the information from the existing pictures. That means there is no labeled ones. Only by using some images or pictures, it will retrieve. It from the retrievation of that information from the pictures, it will create some of the it will predict some of the equations. Some of the applications of this one are the image or video segmentation, anatomy, anomaly detection, and the recommendation system. All things are coming under from the unsupervised learning. Then coming to the semi-supervised learning, it's a mixing of both labeled and unlabeled data. That means it will retrieve the information from the numbers, alphabet, as well as it will retrieve the information from the images, pictures, or videos also. It will retrieve. So for the example for this particular semi-supervised learning is the our speech recognition, in which we are using in our mobile phones. That is coming under the semi-supervised learning. Then coming to the reinforced learning, that means it is purely a virtual reality things. That means in gaming you can see that if you are good in gaming, you can see that every time, every monthly or weekly upgradation is coming to the gaming. So by using the negative feedback from this gaming, we are upgrading our games. So that upgradation of gaming and all things are coming from this reinforced learning. That means it will retrieve the data from the virtual reality, and it will collect the data, and it will make according to that. The machine learning equations will be predicted according to that virtual reality things. Then coming to the transfer learning, and this transfer learning is mainly used in the medical field. That means if you are meeting a doctor, and your doctor is telling that you have to, and you are telling about your problems, and doctor will tell you to do this scanning. That means blood scan. Sorry, you should do CT scan, or you have to check the blood and everything. So from every department you go there and you check all the things. From that he will retrieve all the information from the corresponding lab, and he will finally he will tell you have these diseases. So that is one type of a transfer learning. That means transfer knowledge from one task or domain to another, leveraging pre-trained models for the improved performance. Mainly it is used in the healthcare purposes. Then the next one is self-supervised learning. The self-supervised learning is another part of this supervised learning only. But in supervised learning, we will take data externally. But in the self-supervised learning, we don't take any data from externally. Only from the existing data we will collect the information, and we do the predictions. And moreover, in the self-supervised learning, it's mainly used in the machine maintenance purpose and everything. For example, if I'm working in a lathe, and after 2 or 3 years, if I am going for the maintenance, I have given how much speed I have given, what are the process I have done in that turning process I have done in that process I have done in that lathe machine. All things are coming under this self-supervised learning. That means from the existing data, we will retrieve the information, and we will make some prediction analysis. All things are coming under from the self-supervised learning. Then coming to the applications of machine learning in mechanical engineering and related areas. So if you are a mechanical staff or civil staff or electrical staff, and nowadays all of the engineering colleges are they are promoting AI and ML very much, because it's a future. Actually, it's a future only. So they are including some curriculum in this particular areas. So they will ask. Surely the students will ask us a question: why should sir we should learn the machine learning, or why should we should bother about AI, because we are mechanical students, or we are civil students, or we are triple E students, like that. So the thing is that there are so many applications related to, because this ML is mainly created for the core subjects only. But the all the codings are done by the all the codings and the related algorithms are created by the other firms and everything. So now I am going to discuss about some of the applications of ML in mechanical engineering and related areas. First one is the predictive maintenance. That means the any maintenance task is there. From the existing data, we collect the maintaining things, and we will predict some equation, so that it's very cost effective, and moreover the time less time consuming. Second one is that it is mainly used in the quality control and inspection, then design optimization and process optimization, and robotics and automation, and supply chain and inventory management, material science and research, modeling of properties in manufacturing and thermal engineering, energy efficiency, fault diagnosis and root cause analysis. After this, mainly it is mainly used for modeling some equation predictions. So now I am just going to discuss some of the earth one, that is modeling of properties in manufacturing and thermal engineering. Especially in thermal engineering, I am going to tell. Manufacturing, I will show some case studies. So in thermal engineering, you can see you don't have any particular equation for the calorific value of biomasses. So for that, sorry, for that purposes, that means we don't have a particular equation for finding HHV, higher heating value of the biomass. So that purposes, we will first think that how this HHV is related. So we can say this HHV is a function of its physical properties and the chemical properties of a particular biomass. Physical properties, we can mainly say that it's a proximate analysis values, and chemical properties, we can say it's an ultimate analysis values. So in biomass, we have to we already, for example, I am taking rice as a biomass. Rice has some proximate analysis value and ultimate analysis value. So proximate analysis, maybe that means moisture content, fixed carbon, ash content is there. In ultimate analysis, the presence of carbon, hydrogen, oxygen, nitrogen, and sulfur will be there. So by taking the existing values, I will create some algorithm. So from the algorithm, I will create some equations, so that my modeling of HHV equation is predicted. So I will get a HHV equation for particular rice. That rice means I am not taking the data of one rice, I am taking the data of entire rice. That means around 100 or 300 types of rice I am taking. But then after that, by taking the data, I will create some equations. So that is a main application, one of the in the mechanical engine. Not only biomass area, it can be used in the manufacturing area. In manufacturing area, we can say that in lathe machine, we are the main purpose of a final product is its surface roughness or surface finish. So it doesn't have also particular equation for finding out the surface roughness. So we will take the depth of cut, feed rate and cutting speed and everything. By comparing these values, we will predict one equation. Today I am going to in last of this session, I am going to discuss some of the case study, and I will show how we can predict an equation. So now coming to the similarly in civil engineering field also, they are using so many applications of machine learning, especially in the structural health monitoring, construction planning and management, geotechnical engineering, especially the behavior of soil, and also the assessment of risk of landslide, and then building energy management, then traffic flow prediction and optimization. That means mainly in every metropolitan cities, they are using this type of traffic flow prediction optimization. That they will, it's like a closed loop system. There will be one feedback system will be there. So number of vehicle crosses or particular area, it will capture it, and it will create some algorithm, and it will from the algorithm, the traffic lights will be work. Then material science and quality control, risk assessment and decision support, urban planning, and water resources management, and environmental impact assessment. And these are some of the applications in civil engineering. And we don't have that much of time to elaborate all these things. Then sorry, coming to the electrical engineering, the main electrical engineering things are the power quality improvement, smart builds and home automation, signal processing and communication system, circuit design and optimization. And mainly it is mainly used in robotics and automation. That means the control system of robots for tasks such as path planning, object recognition, and adaptive control are done by using only machine learning. And the predictive maintenance models can be applied in manufacturing equipment in the case of the electronic components manufacturing, and the anomaly detection in electronic system. That means any problem in the electronic system, it will give a buzz by using some of the machine learning algorithms. Then wearable devices and the health monitoring purposes. Now we are going to a case study, especially in the case of a mechanical engineering. We are going to make a case study in the prediction of surface roughness equation for mild steel in turning process. So this in this case study, before that, you have to understand the surface roughness of a particular metal. It depends upon the its manufacturing. So the main factors affecting the surface roughness are its depth of cut, feed rate, feed rate, and the cutting speed. So these are the three factors it will you have to be considered. So here I am using the type supervised machine learning, and the model name is linear regression modeling, and the software I am using is the design expert, and the data all the data which I am going to flourish is taken from the different journals. So design expert offers a first of all I will give an introduction for that software. Design expert is a it's a small software, it's not a big software, and you can easily buy it from the internet. And moreover, the amount of software is very less, but you can use the trial version also from this then. And it is established with the main part of this design expert is the ANOVA, that is analysis of variance, and it is very easily to handle, no need of studying any type of coding or any languages. Only we have to input the data to that particular software. So now I am going to show that one. Okay, sir. Can you see my screen now? Hello?
Yes, sir.
Okay. So here, when you open the this software, you can see one interface is there. So in the interface, you can see standard designs. Standard designs are there. Factorial are there. Response surface mixer. So many type of methods are there. So mainly for my case, I am using this response surface method. It depends. All the designs are there. That means designs are also factorial designs are there. Response surface designs are there. Mixture designs are there. Or custom designs are also there. For my case, because for my thing only I only my in only I only have three input, only I only have one input. So that purpose I am preferring response surface because it is more accurate and also more efficient compared to the factorial method and the mixture method. So I am selecting this response surface method. In this response surface method also there are four types of methods are there. Central composite method is there, box Bengen design is there, optimal method is there, and DSD method is there. All the actually these all four these methods are same, only we will get the design, but it depends upon how much input we are giving. In central composite method, you can see that by default only two input only is there. But in box backend design, you can see three input is there. In optimal also, it depends upon our custom made. You can input more things and everything. So definite screen, it also minimum four input is there. So you can increase in both central composite and box backend method also. No problem. So now I am preferring first method, central composite method. In central composite method, you can see four input. That is A, B, C, D. Actually, I only have three. I only have three inputs, so I am just taking numerical factors as three. So you can see in the screen that only three input are there. So now I am taking my data. So can you see the Excel sheet, sir? Hello, sir.
Yes, sir.
Can you see the Excel sheet?
Yes, sir.
Okay, okay. So here you can see that for five, you can see that cutting speed. Just look the serial number one. That's enough. This just look the serial number one. That's enough. So here the input are 500, 0.1, and 0.2. These are the input for the surface roughness, and the output of that particular surface roughness is the 0.37. So like that, I took 200 data of that one from the different journal. So now I am going to predict an equation for surface roughness. I am going to predict an equation for surface roughness, which are that means which is the function of a cutting speed, feed rate, and depth of cut by using these values, existing values. All these values are taken from the different literatures in the different journals. So first of all, you can see that three inputs are there. First one is the cutting speed, second one is the feed rate and depth of cut. So I am just going to input that on my software. So first one, A, I am putting cutting speed. Just abbreviation, I just make a short form. I am cutting speed. Then feed rate FR and depth of cut DC. I am just putting CS, FR, and DC. And unit I am telling cutting speed unit is RPM or revolution per minute. I am just putting revolution per minute. Revolution per minute. And feed rate, the unit of feed rate is given here mm per minute. I am just putting mm per minute. And depth of cut is mm. Depth of cut is mm. So next column you can see low and high. This low means the minimum value and the high means high value. So in cutting speed, in our data, which is the lower value we have to take and the higher value we have to take. So you can see in the last of this one I already put. From the 200 data of the cutting speed, the lower value is the 100 and the maximum value is the 1900 from this table. From the cutting speed column, you can see from the cutting speed column, you can see that from this cutting speed column, you can see the minimum value of this one is the 100 and the maximum value is the 1900. So I am just inputting the values 100, 1900. And coming to the feed rate, similarly 0.04 and 0.3. I am just putting 0.04 and 0.3. And coming to the next third section, depth of cut, the minimum value is 0.1 and 1.6. 0.1 and 1.6. So I have just put all the maximum and minimum values of my input. And you can see here the total run is 20. But my case, okay, total run is 20 runs. That means 20 runs only I can do. But here I have 200 values. So I had to done 200 runs. For that purpose, I am just optimizing all the things. So here the center points at 6. So I am just increasing 188. Then you can see it is 202. But my run is only 200 run. That means 200 values only I am changing. So I am changing 186. Then I will get the 200 runs. Now you can see that 200 runs, it is that. I mean 200 iteration I am going to be done in the 200 values. So next I am going to put the next, one option is there next. In that I have to put the result. Result means here result we can say that the result is surface roughness. So in the surface roughness I have to put the result. So name I am putting SR as the surface roughness and its unit is micrometer. So only one response are, if there are more than two results, that means you can put two. But here only we only have one result, that is the surface roughness. So we can put up to only one, that is enough, that is SR. Then coming to the finish. Then you will get the some of the default value. Actually, this is the default value. Just delete all the things and we have to just copy paste what are the values here. So I am just copy pasting all the values. So what are the values which is shown in the Excel sheet? Now you can visible in this interface. So I inputted all the things. Now I am going to start the analysis. So now you can see that there is no coding or nothing. Only we have to understand what are the basic concept of the design expert software. Then everything will be okay. Then coming to the you can see in the left side note, summary, graph, column evaluation, and second section is analysis. Just put the analysis. Then you can put the start analysis. So in start analysis, now the equation is generated. That means which is very less consuming compared to ANN modeling and everything. So you can see that here so many type of mathematical things are there: linear, two factorial, quadratic, cubic, quartic, fifth, and sixth. So you can see that in quadratic and cubic they are suggesting, because this software is suggesting that is the you will get the good result in the quadratic and cubic. For that purposes, I am just going to the model. Here model you can see we already tell it is good in the, you can say in the here you can say quadratic and cubic. In FX model, just select the cube. First of all, I am selecting quadratic because quadratic and cubic they are giving the good indication. So now I am going for the ANOVA analysis. So in ANOVA analysis, you can see that model is significant, and you can see this here. You can see the standard deviation. Standard deviation is 0.721, and the R square value is 0.19. But this R square value is very low because this R square value should come nearer to 1. That means 0.99 should become, but it's okay. But its model is significant because its standard deviation is around 0.7219. So here you will get the actual equation. In this tab, you can see the actual equation. Right side, you can see the actual equation. So actual equation, you can see that surface roughness equal to some of the variables into CS into FR minus into some DC like that. You will get the equation. So this is the final equation for finding the surface roughness on the base of CS, FR, CS, FR, and the CS means cutting speed, feed rate, and the depth of cut. Similarly, you can see in the fit summary, you can see that it is a both they are giving both the two things. Quadratic is also significant and cubic. Now I am putting the cubic now because already we put the quadratic. I am going to put cubic. In the cubic also you will get the result. Here you can see the R square value is somehow better compared to the R square value of cubic. So we can take that cubic is more significant compared to the cubic equations are more significant compared to the quadratic equation because the standard value is also less. Earlier stage, the standard value is 0.70, sorry, 0.72, but here is 0.70. And the R square value in the earlier case is 0.19, but R square value is 0.27, which is somehow nearer to 1 compared to 0.19. And you will get the actual equation here. But the equation's length is very big. That's only problem in this one. And also we can generate the corresponding graph by this. So here after now there is one other option is there, diagnostics. In the dynamics, but we can say box course diagram is there. That is not essential, but this predicted and action. So this graph can be generated. This is the important for writing any journals or anything like that. For any students project also, you can prefer this type of projects because it is very simple. Because only need to collect the data. Not only for the manufacturing, any thermal related also you can use these things. So you will get the predicted versus actual graph also you will get this one. This is the one of the case studies. So okay. So these are the results which I get from these two methods. That is, first one is the quadratic is good, and second one is cubic is also good. From the cubic we can see two equations are there, and in two equations you can see the standard deviations are R square values. From this, out of two models, I am preferring this cubic model because its standard value is less, that is 0.70, and the R square value is 0.27, which is somehow nearer to 1 compared to 0.19. So this is the result. More, for example, if I now I am taking only 200 data. If I am taking more than 200 data also, the standard deviation value somehow it will be reduced and the R square value will come to. But that means maximum data will give the accuracy for the machine learning equation. Machine learning equation, that is predictive equation. So collect the maximum values. Maybe if I am collecting about 1,000 data, maybe the standard deviation is somehow nearer to 0 and the R square values is somehow nearer to 1. But the main problem is that the length of the equation is very high in the case of this regression model. That is in the case of regression modeling. So now I am coming to the disadvantages of machine learning because already you know that the core subject, the students are passed from the core subject, they are suffering a lot because nowadays the companies are not following any traditional type of things. They need new type of innovative things and everything. For that, machine learning is an important factor. So by the introduction of machine learning, the job opportunities are nowadays very decreasing, especially in the core fields. And also the lacking familiarity with the machine learning approaches in these areas makes it challenging to access the avenues also. So in my opinion, whenever the new curriculum is introduced, just put machine learning as a supporting subject or the main professional core or the professional LT course in the core subjects. Okay, thank you. As of now, I am concluding because I have a class on 3 o'clock. That's why. Thank you. Hello, sir.
Yes, sir.
Hello. Okay.
Yes, sir.
Okay, so sir. Cannot hear anything, sir. Sir, I cannot hear anything. Hello? Cannot hear anything, man.
Hello.
Hello. Yeah, Emma.
Thank you, Dr. Krishnan, for writing an inspiring session. Your dedication to blending cutting edge technologies with mechanical engineering opens new doors for all of us in academia and beyond. Before we move towards the closure of today's session, I would like to remind everyone to please submit your questionnaires through the link shared with you. Your feedback is invaluable to us. Kindly ensure your submissions should be completed by the end of the event. I would like to remind everyone that our series continues tomorrow, February 8th, with Unlocking Creativity Strategies for Innovating Thinking, presented by Dr. Lakshman Mishra. It's another session you won't want to miss as we delve deeper into realms of innovation and creativity. Thank you for all joining us today. See you tomorrow for more enlightening discussion and learning opportunities. Stay inspired and keep pushing the boundaries of innovation. Thank you.